Okay, so tick aloud question number 1. We have this exponential. State the equation of the inverse. Okay, so I've got the exponential over here typed in. I'll press X here and make sure that the A is all okay. So I'm going to make it equal to X and replace the X with Y instead. So that's replacing X with Y. And go into bracket advanced solve for Y. So it will give me the form of Y equals, which means that I have the negative 1 of X should equal log base E of X on A minus 1 on A. That could have been combined together. Okay, so for the second part, I need to draw the inverse. Well, there's an asymptote here at y equals 1. Therefore, I'm going to asymptote at x equals 1. And I shouldn't have included those numbers on this axis because that's a plus 1. So I'll have an inverse which will look like this, and that will go through at a plus 1. You could have written 2 because I had 2 on your graph. And if I pick another point like point 4, it's going to be at 4 and log base E of 4 on A minus 1 on A, or 3 on A. So 2 points, x-intercept labelled, and the asymptote labelled with its equation. Okay, so find the x-intercepts and the okay, so I'm now going to make analysis G-solve intersection 1.49409. So x equals 1.41. The other intersection is x equals 2.99. And analysis G-solve integral intersection, except the first one, come across except the second one, shaded region 0.63, so area equals 0.63. Find the value of A such that, okay, so I'm interested in the value of A that P and its inverse have one intersection point. So in my bound book, this should be written that if I set up the simultaneous equations, I want P of X equal to X, and I want the derivative of P of X to equal 1. I wish to solve for A and for X. So I'm setting it equal to the line of Y equals X, because where the line of Y equals X touches, the two Y values will be equal to each other, and at the point they'll both have a gradient of 1. So I'm going to take my equation here, copy, come down here, open up simultaneous equations and paste, and I'm going to make that equal X. And I'm going to have this again, and I'll select it all, and I'll take its derivative with respect to X, and I'll set that equal to, and I'll solve that for the variables A and X. And A equals 1 on E squared. Okay, so that's question number 1.